Hello, people. Welcome to another opportunity to learn in the digital space. I'm Mr. Kozad. I'll be going over 9.1 in our textbook, which is on graphing polar coordinates and simple polar equations. So before you do this lesson, I would highly encourage you to go to your Remind and download and print a copy of these slides. It's going to be a lot easier for you. If you didn't get the Remind message from me, you can go to my website through the Stratford homepage, and I will have a link to these notes on there as well that you could get. You could also access the notes on It's Learning if you want to go that route. Okay, so here we go. We're going to jump right in. So what we've done in the past, basically all of your mathematical career, you've graphed in rectangular systems. Rectangular coordinates where you have an x value and a y value, and x tells you left or right, y tells you up or down. But what we're going to look at now is we're going to look at polar coordinates where you've got two different components that tell us two different things. So the first value that you see here, we see a 3. That first value is what's called the directed length. Okay. The second value that you see is going to be a directed measure. Okay, so directed length and a directed measure, or an angle, if you will. So what each one of these rings represent is each one of these rings on this polar grid. This is called a polar grid, and each ring represents one unit. So in other words, one directed distance of 1 unit. So this first ring would be 1, 2, 3, 4, 5, 6. So this graph that you see here is representative of 6 units, if you will. Okay, so the first thing you're going to do is you're going to think about this sort of like the unit circle, to where we're going to start at the origin and we're going to draw the initial side of an angle along the positive x-axis. And we know that we're going to operate at ring number 3, 1, 2, 3. Okay, that's my directed distance. But my directed angle is 5 pi over 6. So you have to remember from the unit circle, how do you locate 5 pi over 6? Okay, and if we remember from the unit circle, 5 pi over 6 is going to be in the second quadrant, and it's going to be the last angle in that quadrant. Okay, so 5 pi over 6. So that's my directed angle, and my directed distance is 3 units. So I'm going to go out on that line, 5 pi over 6, and I'm going to go out 3 units, and I'm going to drop a point off right there. So that's what we'd call point A. Okay? So for point B, B, graph H of 3, negative 120, okay? Remember that negative angles mean we go clockwise, so we're going to start on the initial side, and we're going to go clockwise 120 degrees. Well, 120 degrees, if I'm going clockwise, 90 gets me to the negative y-axis, but I still have to go 30 more, okay? And so it's going to be somewhere along this line. And since my directed distance is 3, I'm going to go out 1, 2, 3 rings and put a point there, and we'll call that H. Okay, now let's see where we can find R, point R, negative 2 and 3 pi over 2. So my distance here, my directed distance is negative 2. Now the fact that that's negative is going to change a little bit about how we do this. So let's find our angle first, our directed angle. So 3 pi over 2 is this, the negative y-axis here, okay? And instead of going from the origin down 2 circles, whenever you have a negative directed distance, that means you're going to go the opposite direction. So we're going to stay on this line. We're going to stay on this line, but instead of going down 2 rings, we're actually going to go the opposite direction 2 rings. So we're actually going to go up 2 units or 2 rings, and that's where the location of point R. Now some of you might have already made this connection, but we can actually see in an example like this that there's another way to represent point R. Okay, so if we wanted another polar coordinate that would end us at point R, we could do something like positive 2 and let my directed angle be pi over 2. Positive 2 pi over 2 would end up at the exact same place as R. Okay, so there's going to be a lot of times where you can use multiple different combinations of polar coordinates to get to the exact same point. So look at part D. Graph Q if Q is -2, -240. So remember, negative angles means we go we go clockwise. So we go 180. This would be to 270. So it looks like this line here is -240. Okay, but because the directed distance is 2, instead of going up 2, I'm actually going to, along that same line, go down to the opposite direction, and that's where point Q is going to be located. Now again, if we think about another way that we could represent point Q, another way we could represent point Q would be +2, and that would be 300. Because if I went 300 counterclockwise, I'd end up at the same place, and to go 2 along that line, +2, 300 degrees. So again, that was an ugly Q, but that is point Q. All right, let's try another one. Okay, here's a problem for you to try. Go ahead where you're at, pause the video if you'd like, and see if you can pick which of these 4 graphs correctly shows you the location of point T. So hopefully at this point you found that solution. You actually paused the video and did the work. So I know that my directed angle is -5 pi over 4. Now that's a little bit more tricky because the way that I do that is I think about where 5 pi over 4 would be if it were positive. So 5 pi over 4 if it were positive would be in quadrant 3, be somewhere down here in quadrant 3. So I'd be traveling 1, 2, and then a little bit into quadrant 3. So if I flip that direction around and I go the other way, okay, if I go the other way, I'm going to go 1 quadrant, 2 quadrant, and a little bit into the 3rd quadrant. So this would be coterminal with 3 pi over 4. So I'm going to find that line. Okay, I'm going to find that line, and because I'm going -2.5, I'm actually going to go backwards 2.5 units. I'm going to go backwards 2.5 units. So that looks to me like the correct answer choice would be D. Because again, -5 pi over 4, I go clockwise, and I'm going to end up right here. But because the directed measure, the directed distance was negative, instead of going along that line 2.5, I go back 2.5. And notice how that point is strategically placed between ring 2 and ring 3, obviously because it's 2.5. Okay, so I've kind of alluded to this already, but we're going to practice it and kind of put it all together. It is possible to find multiple different representations of the location of a polar point with polar coordinates. So this is point S here on your graph, okay? And the limit here is that we're going from -2 pi to +2 pi. That means, if you remember unit circle, that means 1 complete rotation counterclockwise or 1 complete rotation clockwise. So the easiest one to get here would be to think, okay, if I start here, okay, what is my directed angle to get to here? Okay, so very clearly you can see because it's labeled 7 pi over 6. And then I want to look at the directed distance as ring 1, ring 2, ring 3. So one possible point, directed distance of 3, directed angle of 7 pi over 6. Okay? So then brainstorm another way to get to that same point. So what I would do is I'd keep my directed distance as +3, but instead of going counterclockwise, we also could have gone clockwise to get there. So now this is a little tricky. Again, if you're not very good at unit circle, this might be hard for you. But you have to ask yourself the question, okay, if I go clockwise to end here, that's the pi over 6 term in the 2nd quadrant that I passed through. So if you know the unit circle, I would go back to my original and I'd think, okay, what is the pi over 6 term in the 2nd quadrant that I passed through? And that'd be 5 pi over 6. So we're going to do 3, and the directed angle here is -5 pi over 6, because again, we can get to this point going clockwise as well. Okay, so now to find the other two options, instead of assuming that we have positive 3 as our directed distance, we're going to do -3 as our directed distance. Okay, so here's what I think about. To get here, if my directed distance is -3, where the directed angle is really going to be the other way by 3. So 1, 2, 3. So this is where this would be my directed angle, and that's clearly pi over 6. So another way to get point S would be going to pi over 6 counterclockwise, but then backwards 3 units. And the fourth way to do this, -3, okay? So there's another way to get to this terminal side here, and I could be going clockwise. Okay, so that would be quadrant 1, quadrant 2, quadrant 3, into quadrant 4, and I'm looking for the pi over 6 term in quadrant 4. So what I do is I look at my unit circle the way that it's supposed to go, counterclockwise, and I go to quadrant 1, quadrant 2, quadrant 3, quadrant 4, and I'm looking for the pi over 6 term. That's 11 pi over 6. So if I wanted to go from my initial side to this terminal side clockwise, I would go negative 11 pi over 6. Again, I think the logic behind this is really easy, but the hard part for some of you is going to be not knowing your unit circle angles very well. Okay. All right, here's another one for you to try. This time we're in degrees, but go ahead and take a second and see if you can find the 4 different pairs of polar coordinates that name point W on the interval negative 360 to positive 360. Okay, hopefully you actually did that and actually did the work and found that the best representation of the 4 measurements here, 4 polar coordinates, would be answer choice C. Answer choice C. Okay. Hopefully everybody was good with the directed distance of 7 and negative 7. But then again, if you need to go back and practice this, take some time and go back and make sure that you're counting your angles correctly. All right, so the next thing we're going to look at is how do we graph polar equations that are what we kind of call simple equations. Okay, so this first one here is graph the polar equation r equals 2. So what this wants to know is where on this coordinate plane does every is exactly a directed distance of 2 units away from the center. Okay, so what we've got here is we've got a big circle that's 2 units away from the center. We've got a distance that's 2 units away from the center. So then if we look at the second graph, it says graph the polar equation where the directed distance is negative 3.5. Well, this is also going to be a circle, but it's going to be a circle that's, I go out in between ring 3 and ring 4, so that's 1, 2, 3, 4, and that's going to be a circle here. The negative does not affect that because we're still going 3.5 units from the center. And what that circle represents is that represents every point that's 2, in the first case it was every point that's 2 units from the center, and this one's every point that's negative 3.5 units from the center. So if we switch that up a little bit and we look for everywhere on this graph where theta equals pi over 6, the first thing you have to know is where is pi over 6 located. Okay, pi over 6 is located right here in quadrant 2, or 5 pi over 6 is located there in quadrant 2. But remember that this would be, any point on this line would have a positive directed distance. But you remember from previous examples, you can actually have a negative directed distance as well. So we also have to keep that line, but we go back this way as well. So anything on this line would have a theta of 5 pi over 6. Anything on this part of the line in quadrant 2 would have a positive directed distance. Anything on this bottom part of the line would have a negative directed distance. Same kind of concept over here with negative 30. You have to find where that's located first. So that would be 30 degrees clockwise. So anything on this part of the line would have a positive directed distance, but remember you won't always have positive directed distances, so sometimes you'll have to go backwards as well. So anything on that line would have a theta of negative 30 degrees. Okay, last thing you have to do is try one of these on your own. Graph theta equals 7 pi over 4. You have to remember obviously where that's located. Okay, 7 pi over 4 would be in quadrant, not quadrant 1, not quadrant 2 or 3, it's actually in quadrant 4. Okay, so that's right here, anything along this line. But again, this segment of the line assumes that you have a positive directed distance. This part of the line assumes you have a negative directed distance. Answer choice A. That is it for 9-1. It's really short, it's relatively easy, but it is brand new. So using that, if that wasn't good enough, you can check out your textbook, but you are responsible to get this homework done on your own. Thank you. See you next time.